Hello, today we are going to learn about CSTR. Okay, CSTR is also known as Continuous Float Stirred Tank Reactor and is also known as Wet or Back Mix Reactor, which is a common ideal reactor type in chemical engineering. It is also referred to a model used to estimate the key unit operation variables when using a continuous agitated tank reactor to reach a specified output. This model is often used to simplify engineering calculations and can be used to describe research reactors. The CSTR configuration is widely used in industrial application and in wastewater treatment units as well. Okay, the ultimate objective of our experiment is to investigate the effect of temperature on the rate of reaction rate constant, and activation energy of reaction in a batch reactor. The manipulated variable that we set in this experiment is the temperature, which are 50 degrees Celsius and 60 degrees Celsius. The constant variable that we set was the time taken for collecting sample, which was 5 minutes interval from the 0 minute until the 40th minute, and the responding variable was as mentioned in the objective, which are rate of reaction rate of constant, and the activation energy of the reaction. Okay, the method briefly that we use to do this experiment is for every 5 minutes, 3 samples of reacted NaOH solution was collected from the CSTR. The collected samples are then mixed with HCl, then titrated with 0.1 molar of unreacted NaOH, and the average volume of titration is obtained for every reading. This step is repeated until the 40th minute. And with the average volume obtained, the moles of NaOH unreacted is assumed to be the moles of HCl reacted, and the rate of reaction, the reaction rate of constant, and the activation energy of the reaction are calculated as per the objective of this experiment.
Hello guys, my name is Dylan and I will explain the experiment simulation on our CSTR experiment now. Okay, first we open the experiment simulation, and then the reaction we are doing in this experiment simulation is the reaction between ethyl acetate and sodium hydroxide, which produce sodium acetate and ethanol. So first we insert the component ID by finding each component and inserting them, and doing some short prefixes. Okay, moving on, we actually select the base property method, which is the Peng-Robinson method, because ideal does not work when we tried simulating one, so we instead chose the Peng-Robinson, which is a more suitable method to solve the CSTR method. Okay, we move on to the simulation. Okay, this is the main flow sheet of the CSTR, where the number 1 is the input and number 2 is the output. So we chose the CSTR reactor from the model palette, and then okay, now we edit the input. So we start with a temperature of 25 degrees Celsius because we use our liquids at room temperature, and the composition of ethyl acetate and sodium hydroxide is determined when we put inside the reactor by calculation. Okay, and then the total flow basis we use is volume, and the total flow rate is 2.5 liter per minute, since the volume of the reactor is 2.5 liter per minute. Okay, now for the CSTR. The CSTR has 1 atm pressure and 50 degrees Celsius temperature, and the volume is 2.5 liter. Now moving on to the power law and the stoichiometry. The stoichiometry inserted is this, with the reactant having a coefficient of -1 and the product having a coefficient of 1. So we press the next button. The kinetics. The kinetics is we use our K value. We use our K value from our experiment which we did before this, our report, and the E value is also from the report before this. So we choose the values based on the 40th minute time. Okay, the reason we choose the 40th minute time is because it is the very last reading taken, and we assume that is the most accurate reading because it's at the end of the reaction and the peak of the reaction. So we take the K value and the E value from the peak, which is the 40th and the very last reading of our experiment. Okay, moving on. Okay, next we actually move on to the setup of our simulation. So basically you can see the title is all inserted and the stream class is conventional, everything is okay. So we are doing a cross checkup on our control panel, and since we have already run our simulation, so we are still waiting for the results. So now our simulation is completed normally, and as you can see the results are present. So we can move on to the stream summary to check our results. Okay, the results we focused on is the mass concentration, which is gram per liter, and mass fraction. This is all shown in our video here. The mole flow, the mole concentration. Okay, we basically focus on the mole concentration. So basically we take the mole concentration of sodium hydroxide, the final mole concentration of sodium hydroxide, and then what we do with the final mole concentration of sodium hydroxide is we convert it into mole unit by multiplying the volume, average volume used to during titration for the 40th minute. So when we multiplied, we got almost the value of the NaOH unreacted based on our table in our experiment report which we handed in before this. But there are some errors which will be explained further by my group mates in the upcoming part of this video. So that is all from me for the assessment simulation. Thank you.
Hamid?
For the justification of result, by using the Aspen software, the result obtained is 0.002 mole over liter. With further manual experiment, the result obtained is 0.002 mole over liter. So there is a large difference in this result. Because the Aspen software is based on the theory, so the result obtained is more better than the manual experiment, because manual experiment had contained many errors. For the there are many errors that occur for the laboratory experiment. The error is saturation error, equipment error, and the preparation error. For the actual value, the software is no error at all. For example, the saturation error, the experiment was taken 3 samples. It's already reduced the error, but the errors will still consist. For the second error is a equipment error. When using the laboratory size CSTR, the reactor seems to contain some impurities because the equipment is not washed carefully. And the third error is the preparation. During the preparation, the solution before mixing inside the CSTR, the measurement may be inaccurate and it affects the final result also.
Next is conclusion. So by comparing both results from using Aspen software and by manually experimenting in the laboratory, we can see that by using Aspen software, the result will be more accurate as it is basically using the computer to get all the data. And then even though using Aspen software is better to get more accurate results during the experiment, manually also has its own merits. Because by doing the experiment manually, we can get a hands-on learning on how the reactor actually works. Thus, it is recommended doing both methods, which is using Aspen software, and experimenting manually should be done more frequently so that we will have both experience on how to get more accurate results and also on how to how to do the experiment, and understand the process of the CSTR itself. Okay, I think that is all for the completion of this CSTR and the experiment and by doing experiment software. Next we will see how CSTR actually works in industry. This is how it is works in industry.